Let's now look at number 10. Start with 10a. Integral of cos 5x with respect to x. The first thing is let u be equal to 5x. Du over dx will be 5, which means that dx will be du over 5, which means our integral will become cos u multiplied by dx, which is du over 5. Now we can factor out a fifth because it's a constant. So a fifth integral of cos u du. Now the integral of cos u is sine u, so we'll end up with sine u plus c. But u is 5x, so 5x plus c. And that will be our answer. Okay, let's look at B. Same method. Integral of 2 sine 5 minus 3x dx. The first step is let u be equal to 5 minus 3x, which means that du over dx will be negative 3, which means that dx will be du over negative 3. Make the substitution, you end up with 2 sine u multiplied by du over negative 3. Factor out the constants, so negative 2 over 3 integral of sine u du. Now, integral of sine u will be negative cosine u, so negative 2 over 3, and then negative cosine of u plus c, which will give us 2 over 3 cosine u plus c. But we know that u is 5 minus 3x. That will be your final answer. C, integral of a half secant x over 4 dx. Of course, we start with letting u be equal to x over 4, which means that du over dx will be quarter, which means that dx will be 4 du. Make the substitution, so we end up with the integral a half secant of u squared multiplied by dx, which is 4 du. So we'll end up with a half of 4 is 2, so 2 outside secant of u squared du. Now the integral of secant, from the previous table that I showed you, the integral of secant of x squared, or the secant of x squared, I mean the secant of x squared, which is written as the secant, some people call it secant of secant squared x, but that's basically what it means. Now we know that the integral of this is tan x. So our solution here will be 2 tan u plus c, which will be 2 tan whatever u is. So 2 tan x over 4 plus c. So I want to look at some key points. in integration by substitution, there's some key points that you can use. So instead of, especially for simple functions, I'll show you what I mean by simple functions. So you can use some of these key points to basically write the integral of a certain function without necessarily using the method of substitution. For example, if you have a to power ax plus b, the integral of that will be 1 over a e to power ax plus b. You can look at some of the examples that we've worked out, and you'll see that if you integrate this function by substitution, you'll end up with an answer that looks like that. Again, if you have 1 over ax plus b, if you integrate that, you'll end up with 1 over a ln of absolute value of ax plus b plus c. Of course, you have to have c. If you have cosine of ax plus b, if you integrate that, you'll end up with a 1 over a sine ax plus b plus c. If you have sine ax plus b, if you integrate that, you'll end up negative 1 over a cosine ax plus b plus c. If you integrate secant of ax plus b squared, you'll end up with 1 over a tan ax plus b plus c. So these are important results that we can basically generalize from the solutions that we've worked out from the previous questions. And let's try and use those key points to try and differentiate these functions. So I'll try to use those shortcuts instead of doing the long way. Anyway, start with the first one, the integral of 2 sine x cos x dx. Now, from our knowledge in trigonometry, we know that 2 sine x cos x is same as the integral of sine 2x. And then if you use one of those rules, okay, this one here, the second last one, if you use that rule, the integral of this will just be, so we know that the integral of sine is negative cosine, so negative cosine 2x, and then you divide by 2 plus c. So our answer will be negative a half cos 2x plus c. That's it. For b, we have the integral of 2 cosine of 3x squared minus 1 dx. So the first step is try inspecting, and if you can use one of the trig identities to simplify that expression. Now we know that cosine 2 theta is equal to, and this is available in our formula booklets. So using that identity, we can simplify this expression inside our bracket. Okay, so this here is basically our theta, which means 2 theta will be 6x. So what you're basically saying here is this is same as integral of cos 6 cos 6x dx. And using one of those shortcuts, the key points that I mentioned previously, this is the same as the integral of cosine is sine. So sine 6x divided by 6 plus c, which will be 6th sine 6x plus c. And then c, we have the integral of tan x over 3 squared plus 1 dx. So basically here, we need again to try and inspect this identity. See if we can simplify it. Now we know that tan theta squared plus 1 is equals to the secant of theta. So our theta here is basically x over 3 using this identity here, which means I can simplify this integral to end up with a integral of and I forgot something here. This is secant squared. Okay, so I'll end up with a integral of secant x over 3 squared dx. And then using one of those shortcuts that I showed in the previous page, we can end up with, we know that the integral of secant squared x over 3 is tan x over 3. So my answer will be tan x over 3 divided by a third plus c, which is the same as 3 tan x over 3 plus c. Here are some other questions. So I'm just gonna go through them one by one. So anyway, the first one, A, integral of 4 minus x cubed plus 5 cos 2x dx. That will give me 4x minus x to the power 4 over 4. Just integrate term by term. Plus, now this will be 5 sine 2x over 2. 5 sine 2x over 2 plus c, which means we have 4x minus x to the power 4 over 4 plus 5 over 2 sine 2x plus c. For B, I have the integral of 7e to the power x minus 3x squared plus 1 minus 2 sine 2x. Integrate that with respect to x. I'll end up with 7e to the power x, that doesn't change, 3x cubed over 3 plus x minus, now 2 sine 2x will be negative cos 2x over 2 plus c, which means if I simplify this, I'll end up with 7e to the power x minus x cubed plus x plus cos 2x plus c.